Hello student, I am Shilang Singh, your instructor for this course. In the previous section of the tutorial, we have started with properties of determinant. And till now we have learned 4 properties. Now let us go to property number 5. If each element of a line consists of m terms, the determinant can be expressed as sum of m determinants. Now consider the determinant delta equals determinant a1, b1, c1 plus d1 minus e1, a2, b2, c2 plus d2 minus e2, a3, b3, c3 plus d3 minus e3. Now you can see that each element of column 3 of determinant delta consists of 3 terms in term of C, D and E. Expanding delta by column 3, we get C1 plus D1 minus E1 into product of A2 B3 minus product of A3 B2 minus C2 plus D2 minus E2 into product of A1 B3 minus product of A3 B1 plus C3 plus D3 minus E3 into product of A1 B2 minus product of A2 B1. Now taking C1 into product of A2 B3 minus product of A3 B2 minus C2 into product of A1 B3 minus product of A3 B1 plus C3 into product of A1 B2 minus product of A2 B1 together D1 into product of A2 B3 minus product of A3 B2 minus D2 into product of A1 B3 minus product of A3 B1 plus D3 into product of A1 B2 minus product of A2 B1 together and minus E1 into product of A2 B3 minus product of A3 B2 minus or minus plus E2 into product of A1 B3 minus product of A3 B1 minus E3 into product of A1 B2 minus product of A2 B1 together. We get this expression by taking minus outside. Now if you see properly, the first determinant of this expression, that is this one, is expansion, and its expansion is this term along column 3, that is C1 into product of A2 B3 minus product of A3 B2 minus C2 into product of A1 B3 minus product of A3 B1 plus C3 into product of A1 B2 minus product of A2 B1. Similarly, second term of this expression is expansion of this determinant along column 3, and third expression, that is third term of this determinant, is expansion of third determinant of this expression along column 3, that is over here. Hence the statement, that is, if each element of a line consists of m term, the determinant can be expressed as sum of m determinant. That is over here, delta, in delta, each element of column 3 consists of 3 terms in term of C, D and E. Hence delta can be expressed as sum of 3 determinant over here. Further, if the element of 3 parallel lines consist of m, n and p term respectively, the determinant can be expressed as the sum of m cross n cross p determinant. Now property number 6. If to each element of a line be added equimultiple of the corresponding element of one or more parallel line, the determinant remains unaltered. Let delta be the notational form of determinant. Then to each element of column 1 of delta add p times the corresponding element of column 2 and minus q times the corresponding element of column 3. We obtain delta dash, that is A11 plus P times A12 minus Q times A13, A12, A13, A21 plus P times A22 minus Q times A23, A22, A23, A31 plus P times A32 minus Q times A33, A32, A33. Now by using property number 5, you can see that in column 1 of determinant delta dash, each element consists of 3 terms. So according to property number 5, delta dash can be expressed as sum of 3 determinants. Now the second determinant over here, you can see that each element of column 1 is P times the multiple of each element of column 2. So by using corollary of property number 4, we can say that this determinant result will be equals to 0. Similarly, each element of column 1 in determinant 3 is minus q times multiple of each element of column 3. Thus, value of third determinant will also be equals to 0. That is, delta dash will be equal to notational form of this determinant plus 0 plus 0. Now you can see that this determinant is exactly same as this determinant, which is for delta. Thus delta dash equals delta. Hence the statement, that is, if to each element of a line be added equimultiple of the corresponding element of one or more parallel line, the determinant remains unaltered. Note 1. This property is very useful for simplifying determinants. To add equimultiple of parallel line, we shall employ the following notations. Suppose to the element of the second row, we add P times the element of first row and Q times the element of the third row. Then we say operate R2 as R2 plus P times R1 plus Q times R3. Similarly, operate C3 as C3 plus M times C1 minus N times C2, means that to the element of the third column add M times the element of the first column and minus N times the element of the second column. Note 2. It should be noted that while applying operation on determinant, then at least one row or column must remain unchanged, or maximum number of operation equals order of determinant minus 1. That is, over here you can see that when R2 is changed as R2 plus PR1 plus QR3, R2 is kept as it is, while the two lines, that is R1 and R3, are changed as P times R1 and Q times R3. Similarly, over here when C3 is changed as C3 plus MC1 minus NC2, C3 is kept as it is, while C1 is changed as MC1 and C2 is changed as minus NC2. Note 3. It should be noted that if the row or column which is changed by multiplying a non-zero number, then the determinant will be divided by that number. Now, we will understand this property in a much better way when we solve problem based on this property in the further tutorial.